In this video, we're going to solve the Ka for an unknown weak acid. We'll skip exactly how we know in this case, but I have a mixture that's 0.01 molar of the weak acid with 0.25 molar of the weak base. This has a pH of 6.23. What is the Ka of this? Well, there's two ways we can go about solving this. We can do the full equilibrium expression, or we can use the Henderson-Hasselbalch equation. So let's do both. I could have my acid, so HA in equilibrium with H plus and A minus, whatever the acid and the conjugate base are. Well, in this case, I know all the amounts. I know my concentrations of weak acid and weak base, and I have the pH, so I know the concentration of H plus. 0.01 acid, 0.25 base, 10 to the negative 6.23 for the H plus. My Ka must equal my products over my reactants. So if I'm at equilibrium and have these concentrations, I can simply plug them in to solve my Ka. 10 to the negative 6.23, 0.25 over 0.01. Multiply all that out, solve my Ka. And I'll find a Ka of 1.47 times 10 to the minus 5. Now, if we want to do that via the Henderson-Hasselbalch equation, our pH is equal to our pKa plus the log of my base concentration over my acid. So we could rearrange a little bit. I can find that my pH minus the log of that ratio must equal my pKa. So 6.23 minus log of 0.025 over 0.01 minus the log of 0.25 over 0.01 must equal my pKa. 6.23 minus 1.398 must equal my pKa. So 4.832 must equal my pKa. Well, how do I turn my pKa back into a Ka? Much like for pH, 10 to the negative pKa is going to give us our Ka. And we will find that that Ka is 1.47 times 10 to the minus 5. So whichever route you want to take to solve for it, if we know the pH of a known mixture, we can solve the Ka for that weak acid's dissociation constant. Let's give that a try with another one. Let's have an acid at 0.15 molar, a conjugate base at 0.0035 molar, and a pH equal to 9.73. Go ahead and pause, solve the Ka for that, and then come on back. So what would our Ka be here? Well, my Ka is going to equal my H plus concentration, 10 to the minus 9.73, my base concentration, 0.0035, divided by my acid concentration, 0.15. And I solve that out to be 4.34 times 10 to the minus 12.